So, hello everyone. I hope you guys are doing fine and good. Would also like to thank you for your response for my previous videos. So, now I'm going to explain another type of complexity that we usually deal while writing the code. What is that kind of complexity? That is what we call it as space complexity. What is space complexity? Space complexity is nothing but the overall space that is occupied by your program while you're writing the code. It is the space that is occupied by the kind of data structures that you're using, the inputs that you put in the code, and the output variables of the code. Much more confined, space complexity also depends upon the input n or the number of inputs that you give to a particular code. Moving further, space complexity can be defined as, or what is the formula for space complexity? It is the space that is occupied by the variables, input variables, output variables, or input variables and output variables plus the auxiliary space. Auxiliary space is the space that is occupied by the temporary variables. So space complexity is also expressed as big O of n notation, where n is the number of inputs that is given to a particular program. What is auxiliary space? Auxiliary space is nothing but the temporary space that is occupied by your program. The auxiliary space is more prominently, more confined, is more perfectly can be explained while using recursion. When we recurse a particular function over and over again in a programming language, we call the function over and over again, and each function or the result of a function is stored in a stack. So this stack is considered as an auxiliary space to a particular program. So what is the usual data types that are used in Java, and what is the size that it usually takes in order to define these set of variables? One of which is byte. Byte is the most smallest data type in Java, which occupies the 8 bits. Then we have short, occupying 16 bits. We have int, long, float, double, char, and boolean with their respective size that they usually occupy. Now, with the help of a simple code, I'm going to explain you the different types of space complexities and how do we assign space complexities. So, to understand space complexity, I'm going to create a small class called space. And then I'll head over to the class. Here the already present content and usually type. By far now, you would have got a fair idea about what inputs.java.io does. And then I'll declare a class called space and then create the main function. And as according to the previous part where I explained what is the amount of bytes that are assigned to a variable that is defined as int, it is 4 bytes are being given to store this. When we assign a data type to a particular variable, we allocate certain amount of spaces allocated in the memory. For int variable, it is getting allocated to 4 bytes. So I'll just define a variable called a is equal to 3. I'll define another variable called nb, and I will just do a plus plus in there. So what is the amount of space that is given to this set of variables? So to understand that, 4 bytes will be assigned to a variable and 4 bytes will be assigned to b variable. So there is no input that is given in this program, so it will only depend the total number of bytes that are assigned is a constant, which is 8 bytes are given to this particular program. So hence we say that this program has O of 1 complexity. Now let us go ahead and understand ON complexity, ON space complexity. Let me write it space here since it is space complexity. Now I'm going to define an array. Array is nothing but a set of similar data types. So when I define how to define an array in Java is when I write int a and then I open and close square brackets and I say new int and I just give some random space to that value. Say I'll just say 10. So when I say 10, I'm also defining a specific value to an array. So hence this will also take constant time complexity, which means 10 contiguous locations for that particular array A is being created in the memory. So we have O1 space complexity till now. Now let us try changing that. Oh, I'm sorry, since variable array A is already being defined, I cannot use the same name, so I'll define it as A1. And then what I'll do is, I'll just take an input n. You can also take the input from the scanner class. Sc is equal to new scanner system.n. So it is giving me an error that scanner class is not found. So hence I need to import the java.urls package to get this scanner class. And so now the error is gone. I can compile this value, and what I can do is I'll just take int n is equal to new this sc.nextIn, which means it will take over any next value of integer that is gonna come in system.in, or which will be given by the user. And so now at the end, the value of n is defined or has been taken. I'll just display a message to the user that he needs to enter a value. Please enter some value. So integer value to be specific. So hence now we will take an integer value, and now I'm gonna assign the value to n. So now this array is getting assigned, which is dependent on n, the input that we are given. So now it will become ON complexity, since it depends on the value of the number of the space that is being assigned. So whenever I say int I equals 0, I less than n, I plus plus, now I'm taking an input value and storing it in an array. This is how we index an array. We are just moving I from I till n, that is from 0 to 9. The index of an array always starts from 0, and I'll also take this from the user. The values of array, I can also take it from the user. All I do is just do sc.nextIn. That's perfect. I'll just copy this and just say, please enter the value. Please enter values in the array. So now this is gonna take ON space complexity. My bad, it's A1. The array name is A1. So I just compile this array and then I'll run. All I get in the console, where is the console? There is the console. Please enter some integer value. I'll enter, say, 4. Now we can enter the values like 1, 2, 3, 4. And that's it. The program is done. So what I'll do is I'll just display the values that are stored in the array. So what I'm going to do is system. Now the println. This is the function that is used to display all the values in array. That is, it will convert the array into a string and display the values, because or else you need to loop over it and display all the values separately. So it will directly convert it into string and display the value. That is A1. So I've stored, and now I'm going to display. It is again going to ask me the value, what is the length of the array. So since the length of the array is now dependent on n, it has O(n) space complexity. I have 1, 2, 3, 4. So you can look at the array. It has 4 locations, 4 contiguous locations in the memory are now assigned to this array, which has the numbers 1, 2, 3, 4. So what is the total amount of values, or what is the total amount of space that is allocated to this set of array is 4 times 4. That is 16 bytes of memory location is allocated to this array. So hence it is dependent on n. It has O(n) space complexity. So we have talked about O(n) space complexity. Similarly, we can have O(n) squared space complexity if we have a 2-dimensional array. If in case we have a 2-dimensional array, now it now depends on n times of n. That is O(n) squared complexity. That is O(n) squared complexity. So that is how we define the space complexity of a particular program. In competitive programming, it should not exceed a certain value that is mentioned. So hence, we need to have additional complex data structures in order to reduce the space complexity of a particular program. Can the space complexity be O log n, or can it be O(n)? Absolutely, why not? I'll show you an example of time complexity, the space complexity of a particular program being O log n. I'll write a simple code, say, I'll call it space 1. I'll copy the basic part of the code from this program, and then I'll just paste it here. I cannot name one space class has been already been given to some other class, so hence it was throwing an error to me. I've changed the name of the class. So all I'm going to do is write a program that is going to display the space complexity of O log n. So for that, I just have to create a particular function called public static void. It returns an integer value, of course, called function int n is the value that is what we are going to take from the user, int n in sum, and then all I'm going to do is I'm going to recurse this program if n is greater than 1, take sum is equal to sum plus 1. So the condition that I'm showing you is what we call it as the base condition of a particular recursion problem. Unless and until the base condition is met, it is going to recurse. The function is going to go recursively. It's going to call itself as till the base condition is met. We are going to return function of, say, n divided by 3, comma, I'll also have to return sum because those are the parameters given to that particular function. And then we have else return the value of sum. So I've put forward, say I'll take value, since I've already deleted scanner.sc, I'm just bored not to write it back again. So I'll consider value of n to be 10. I'll take system.out.println, call this function, and this function's value of, I'm going to pass the value of n and say value of sum. Sum is 0 in this case. So what is the output that what we're going to, what we expect? So let me tell you how it's going to function here. So at the first instance, n value is 10, it will go to the particular function. Is 10 greater than 1? Yes. So it will go inside, it will add 10 to the sum, and again call back the function, dividing n by 3. So now, since it's an integer value, it will return back a function having n value 3 now, and some value 0. So again, if n is greater than 3, it will add 3 to the sum, which was previously 10. So sum was previously 10 because n was 10. Now the new value of n is 3. So here n is 10, and that's evidently greater than 1. And we have some value equals 10. And now n value becomes 3 because we are recalling the function n is equal to n divided by 3, that is 10 divided by 3, which equals 3. And then again we are calling back n equals 3. Now n equals 3 and sum equals 10 to the new call. N is greater than 1, that's quite evidently visible. And so now sum is equal to 10 plus 3, which is going to be 30. And now the value of n will become 1, which is fairly not greater than 1, it's equal to 1. So hence it will go back within the value of sum, that is 30. So hence it will hover it back to the previous value of the function that it had called, and again back, giving the value of sum equals 30. I'll explain it more precisely in the further part of the video. Let's go ahead and check the output of the program. Okay, I'm sorry, I have not commented it out. How to give multi-line comment is just like recollecting it right now. With 3 dots, that's in Python. Okay, for a time being, is it okay? For a time being, all I just do is comment it all out, or just remove it. I'll just check over to what was the syntax of multi-line comment. I'm not recollecting it right now. So we'll go ahead and check the output of this video. What is going to be, so according to my evaluation, it has to be 30. So the value is certain. I'll clear up the console so that it's evidently visible. So that's the value, 30. So now I'm going to explain you how recursion actually functions and why its complexity is going to be O log n. Its time complexity is also O log n. So yeah, coming back to the code, we got the output of sum equals 30, right? So how is that possible? So what is recursion? Recursion is nothing but calling a function back and back over again till you meet the base condition. What is the base condition in this case? The base condition in this case is n greater than 1. So let me just show you how things go ahead in this stack. That is what is going to determine our space complexity here. So here we have the stack. Let me create a stack. I hope you're just gonna require 2 of it. So I'm just creating 2 boxes. So at first instance, we are calling a function of say 10 comma sum which is 0 at the first instance. I'll create another one if in case we need to do so. Hence this function is called first, and so let's say we store this function in the stack. So this function, say we call it the first function, is stored in the stack. Then, as I've already explained it to you, is n, is n greater than 1? N is 10 is 10 in this case. Yes, it is greater than 1. So sum will be equal to sum plus n. So sum will now be equal to 10. Back again. So sum is now equal to 10. Then what happens is now the value of n gets reduced it gets reduced as it is getting divided by 3. So we have n equals divided by 3. So n is now equal to 3 since n is 10. We are taking the integer values. So is 3. Now we have another call to the function. This is the second call. What is the second call? The second call is function of, say, 3, 10. That is the new function. So we call it as function number 2. So this is the second function that is stored here. And then finally, we have is n greater than 1? It's true. It satisfies this condition. So sum is 10 before. So sum is equal to sum plus 3, that is 10 plus 3, and that equals 13. And now again the function is called. That is function. Still, these haven't got their answer since the base condition is not met yet. So the function is now 1, 13. So we have sum equals 13 and n has again got divided by 3, which was 3 previously. So n is 3 by 3, which is 1. And now we define it as the third call. Define it as the third call. But we define it as the third call? Exactly. So hence, then we meet the base condition. So what does the base condition equal to? Base condition is now we are 1 and 1 is not greater than 1. So hence it will go into the else part and return sum. So we have got the response to the third function, that is for 1 and 13 we have got the response as sum equals 13. So the response is 13. That will be given back to this part, and it has also got that will be returned back to this function, which will even have, so it will be like return of return so it will be like return of it will be just return of the value that we have got, that is sum equals 13. So here we again have sum equals 13 that will return back to the first call, and hence we get the output as 13. So giving more clarity of what is going on is we get what is the first function called. So what is the first function called? The first function called is, I'm just writing it in short form. The first function call was 10, 0. The second function call that is stored in the stack is 3, 10. And the final call is fun of 1, 13. And this gets the value of sum equals 13, which was eventually called by this function that gets the value of 13, and which is eventually called by this function which gets the value of 13. So hence we have 13. So how we will calculate the space complexity? So to evaluate the space complexity, all we need to do is, what is the amount of space that is occupied in the stack, which will also assign to the auxiliary time complexity. So hence, how many times do we have to divide the value of n, that is k is the number of times that we have, so that it gets reduced to 1. That is, n gets reduced to 1. So we'll have n is equal to 3 raised to k. Taking log on both sides, we have log n, and then we have log 3 raised to k. So according to the logarithmic values, we will have log 3, k log 3, and then we have log n, and then finally k is equal to log n by log 3, and that is equal to log of n to the base 3. So hence, this will be the space complexity, space complexity of the program, which is space complexity of the program, which is dependent on log of n. So what is it? O log of n. And similarly, will be the time complexity of this program, which will also depend on log of n. So this is how we'll have this is how we evaluate the space complexity of the program. Now, what is the next question? What will be the auxiliary